Good morning, students. Today we are going to talk about atomic theory. Then it all starts from matter. So you need to know the definition of matter. What is matter? Matter is simply defined as anything that takes up space and it has weight. Okay. Then matter has four categories: solid, liquid, gas, and plasma. A perfect example that we can use to define matter is H2O, which we all know as water, because water can be in all these different forms. When we drink water, it becomes a liquid. But if you put water inside your freezer, it changes to ice, which is a solid. But if you boil water in the morning, it first becomes water vapor, which is a combination of liquid and a gas. Because it's water and vapor, then it's referred to as plasma. Then afterwards it changes to just normal gas, which is a gas. So water can be in all those four different categories. Okay. Then any combination, as you can see, H2O, which we used as our example, is a combination of hydrogen and oxygen. We refer to this as a compound. So that's why we define a compound as a combination of different elements. Okay. Then the difference between a molecule and a compound is that even though they are both combinations of hydrogen and oxygen, if we take about this example of water, a glass full of water is then referred to as a compound because it's a combination of different molecules. But what is a molecule then is just a tiny drop of water. So a molecule simply means a tiny drop of water, or it's the same as a compound. It's defined as the smallest particle of this compound, which can be on its own but still has the properties of that compound. Meaning, if it's a combination of hydrogen and oxygen, it's the smallest part. Just if you boil water in the morning, just before it changes to hydrogen and oxygen, it first becomes a molecule. Okay. Then if you break a molecule, then it becomes hydrogen and oxygen, which are simply referred to as element. So how do we define an element then? An element is anything that you cannot reduce or change, because hydrogen will always remain hydrogen, oxygen will always remain oxygen. But even though we can't break them, they also have small building blocks, which we refer to them as atoms, which is what we are going to discuss now. Okay. Then we said atoms are small building blocks of element. So we are going now to discuss what is an atom. So all atoms have a tiny heart, which we refer to it as a nucleus. Then what particles do you find inside your nucleus? So inside your nucleus, you will always find positive charges. And we refer to these positive charges as protons. So protons are positive. Yeah. Then we all know the law of charges, that if you have like charges, they always repel one another. So we don't want those protons to repel one another. Between the protons, we have other charges, just to prevent the protons from repelling one another. And we refer to these charges as neutrons. And they are neutral, meaning they don't have a charge. So if inside the nucleus then we have protons which are positive and neutrons which don't have a charge, we can easily say then our nucleus is positively charged. So nucleus is positive as well, because it contains protons which are positive and neutrons which don't have a charge. Then around the nucleus, you have a cloud of lines which we refer to them as orbits. Okay, all these lines are referred to as orbits, or simply a shell. So these lines are referred to as orbit or a shell. Okay. Then the last shell has a name. And the last shell is called the valence shell. So how do we define a valence shell? Valence shell simply means the last shell or the outermost shell. Okay. Then what do we find inside the orbits or the shells? We find negative charges. which are rotating at high velocities around the nucleus. Then these negative charges are referred to as electrons. They rotate at high velocity around this nucleus. Okay. Then remember, earlier we said the outermost shell is called the valence shell. Inside this valence shell, we also to have electrons as well, and we refer to these electrons as valence electron. Then how will you define a valence electron? Then simplest definition is that a valence electron is the electron in the valence shell, or a valence electron is the electron in the outermost shell. Okay. Then what else can we see in our structure? Oh, before we discuss that, what is a valence shell? Oh, this valence shell, the maximum of this valence electron is 8. So maximum is 8. We can only have 8 electrons in the outermost shell, regardless of the maximum number of electrons that this shell can take. Why is that so? It's because these cells are used to determine electrical properties of atoms. So we are all starting to become electricians. If you are starting to be an electrician, you know that there's a copper wire that is used to transfer electrons, and you have the rubber outside the copper wire which does not transfer electrons. All that it's because of the number of valence electrons, but we'll discuss that later. Okay. Then earlier we said if you have like charges, they repel one another. But what happens if you have a positive and a negative? Unlike charges will always attract one another, meaning these electrons will always tend to move towards the nucleus, because a nucleus, earlier we said a nucleus is positive, then electrons are negative. So positive and a negative will always attract one another, meaning if you want to attract anything, you need to apply a force. We'll refer to this force as the force of attraction. So how do we define force of attraction? It's simply a force that exists between positively charged protons and negatively charged electrons. Okay. Then we also said these electrons are rotating at high velocities around the nucleus, meaning they will always tend to move away from the nucleus, meaning we will also have another force. Then this force, second force, is called centrifugal force. This force exists because electrons are rotating at high velocities around the nucleus, meaning they tend to move away from the nucleus. But all we have to know is that these two forces are always equal in magnitude, but as we can see, they are acting in opposite directions, meaning this electron will always remain in its shell, or we sometimes call these shells energy levels. So the electrons will always remain. That's why at home, if you have load shedding, you cannot cook, you can't do anything. It does not mean you don't have electrons. Simply means you do have electrons, but because the two forces are equal to one another, they will just cancel one another out. Okay. Then we said the reason we cannot cook or do anything at home if we have load shedding, it's because these forces are equal in magnitude, but they are acting in opposite direction. So what needs to happen then in order for us to move electrons? All you have to remember, guys, is that the electricity that we have at home is just a movement of electrons away from the nucleus, meaning the only way to move this electron is if you add now a third force. This third force, let me write it this side, it's called EMF. If in your test the question is name two forces that act on an orbiting electron, please only mention these two forces: force of attraction and centrifugal. Then the EMF is just there to move electrons, meaning what ESCOM does, it just gives you the EMF. What does the word EMF mean? It means electromotive force. From the word electromotive force, guys, the word motive comes from the word motion. So this force is just a force that will set these electrons in motion. So now, if you look at the forces now, we have two forces that are pushing the electron away from the nucleus. Then you only have one force that's pushing the electron towards the nucleus. So in which direction then will this electron move? So obviously, it will move away from the nucleus. So it moves from the first shell to the second shell, then it moves to the last shell. Then remember we said if it's in the last shell, it becomes a valence electron. But what happens if you continue pushing it away from the valence shell? Then it will leave this parent nucleus. That's when we refer to that electron as a free electron. What is a free electron then? Just an electron that has left its parent nucleus, or you can define it as an electron that has been released. Okay. What else must we know about the atoms is that all atoms are electrically neutral. For them to be neutral, it does not mean they don't have protons and they don't have electrons. It simply means the protons are equal to the electrons. So all atoms are electrically neutral because they have the same number of protons and electrons. But now we are saying if we are adding a third force, which we call an EMF, one electron will move. Then we are saying if now our electrons, so if our atoms have the same number of protons and electrons, they are neutral. Meaning, before we add this EMF, or before you switch on your light, your switch at home, your atoms inside the copper wires are neutral. Okay. Then let's say this is atom A, then this is atom B. Okay. Then we said if you add an EMF, it pushes one electron away from atom A, becomes a free electron. But where will this free electron go? It goes over to atom B. Then if now you can look at it here. At atom A, we pushed one electron away. So therefore now atom A, instead of having 10 protons equal to 10 electrons, atom A now will have 9 electrons because one electron has moved. Then what's going to happen to atom B? Atom B also had 10 protons which were equal to 10 electrons. What's going to happen to atom B now? It will have 11 electrons. Okay. Now if we look at atom A and atom B, are they neutral now? No, because they don't have the same number of protons and electrons. So in electrical engineering, we only talk about two charges. It's either something becomes positive or something becomes negative. If you look at atom A has 10 protons which are positive and 9 electrons which are negative, meaning it has more positive charges than negative charges. So therefore, this atom now becomes what we call a positive ion. Okay, so in terms of test, what would be a positive ion then? Positive ion, it's simply an atom that has more protons than electrons. Then as an N2 student, you need to give us a reason as well. Why is that so? It's because they have lost one electron. So simplest definition of a positive ion is an atom that has lost an electron, therefore it has more positive charges than negative charges. Another name for a positive ion is called a cation. Okay, so now we must know that atom A becomes a positive ion or a cation. But what about atom B? Atom B gained one electron, so therefore it has more negative charges than positive charges. There's no way then that it can also become positive, and we refer to atom B as a negative ion or an anion. So what's the difference then between a positive ion and a negative ion? Is that a positive ion loses electrons and has more positive charges, while a negative ion gains electrons and has more negative charges. Please don't write the statement that a positive ion is positive and a negative ion is negative. Simplest difference between the two is that positive ion, they lose, negative, they gain. Positive ion, they have more positive charges, while negative ions have more negative charges. Then what is that process? That process is called ionization. How do we define ionization? Ionization is simply a process whereby atoms lose or gain electrons. Okay. Then what is an ion? An ion is simply a charged atom. Once an atom has a charge, it becomes an ion. An example of ionization, guys, it's when you rub paper and a ruler. If you rub paper and a ruler, at some point you will notice they will attract one another. Why are they attracting one another? It's because maybe the paper will lose electrons and becomes positive, while your ruler will gain electrons and become negative. What happens if you have a positive and a negative? They always attract one another. Okay. Then we said we use valence electrons are used to determine the properties of atoms. Now we'll discuss our 4 categories that we have. Okay. So the first category that we have is called a conductor. So what is a conductor then? A conductor is any atom that has less than 4 valence electrons. Meaning if it has 1 or 2 or 3 in its outermost shell, it's referred to as a conductor. Or like the piece of copper wire that you have inside your wires at home. Then if it has 4, then it's called a semiconductor. So semiconductors, something that is exactly 4, then 5, 6 or 7 are all referred to as resistors. Then if something is exactly 8, then it's referred to as an insulator. So those are the 4 categories that we have. Less than 4 conductor, 4 is semi, 5, 6, 7 resistors, and exactly 8 is an insulator. But remember, an outermost shell can only be full if it has 8. So if now we can compare resistors with conductors, we can all see that if we combine 7 and 1, what do we get? 8. Meaning, in this case, something called chemical reaction will have to take place. One of these atoms must be willing to lose and the other one must be willing to gain. But if you look at a resistor has 7. It only needs 1 more to get to 8. Will it be willing to donate its 7 electrons to a conductor? Or a conductor only has 1. So will it be the one that will be willing to lose its 1 electron to a resistor? Obviously, the one that needs more will lose. So in this case, 7 and 1 chemical reaction will take place, but a conductor will give up its electron to a resistor to make 8. Same scenario. What about 6 and 2? 6 and 2, we do get 8. Again, a resistor has 6, it needs more to get to 8, so therefore there's no way that it will be willing to give up, so therefore a conductor will give up again. What about 3 and 5? Same scenario. Resistor has more than conductors. So what else can we conclude then about conductors? We have seen that if you place them closer to resistors, they always give up their electrons. That's why we even refer to them as conductors. That's why we use them to carry electricity from power stations to our homes, because they always give up electrons, because they always need more to get to 8. So another conclusion about conductors that we can write is that they always give up their electrons. Always. What about resistors? Is there any way that they can give up their electrons? There is no way. So therefore, we can also conclude then that resistors have between 4 to 8 valence electrons, but always gain electrons. Always. Okay. Now, let's look at semiconductors. Let's say I have a semiconductor with 4. I also have another semiconductor with 4. Now we know that in order for them to get to 8, one needs to be willing to lose and the other one must be willing to gain. But in this case, atom A has 4. It needs 4 more to get to 8. B also has 4. It needs 4 to get to 8. So they need the equal number of electrons to get to 8. So will they be willing to lose or gain? No. So that's why in semiconductors, we can conclude that they will always share their electrons. Okay. In all atoms, guys, there are 3 ways that chemical reaction can take place. It's either by losing, or by gaining, or by sharing. Because in this case, they need the same number to get to 8. Therefore, they will never, ever lose or gain. Then in the next video, we will discuss how do they share their electrons. For now, just know that a semiconductor will always share. That's why then a semiconductor is not a good conductor, plus it's not a good insulator. Okay. Then let's look at insulators. Let's say now atom A becomes an insulator with 8. Then atom B is a conductor with 1. Earlier we said conductors are always willing to give their electrons away. But if an insulator already has 8, will it be willing to accommodate, or does it have a space to accommodate this electron? No. So the first conclusion that we can make is that all insulators don't have a space in their valence shell to accommodate any electrons. Therefore, they will never gain like resistors. But what happens if you put an insulator next now to a resistor? Earlier we said all resistors are willing to gain electrons, but this already has 8. Will it be willing to lose 1 electron and then go somewhere to find that electron? The obvious answer then is no. So what can we conclude about insulators then? They neither lose nor gain electrons. That's why if you touch the rubber outside your wires at home, you don't feel anything, because in insulators, no chemical reaction will take place because its outermost shell is already full. Okay, then in the next video, we will discuss semiconductors.